Hello everyone, we have here a plane trigonometry word problem. A surveyor is standing at a distance from the tower and on the same plane as the base, observed by means of a transit that's 1.5 meter high, that the angle of elevation to the top of the tower was 55 degrees. Then he moved his instrument 60 meters farther away from his position. He observed that the angle of elevation was 40 degrees. Find the height of the tower. So here is the illustration or sketch of the problem. Not to scale, and here indicated the tower, and here indicated the ground, where the surveyor stood on the same plane as the base of the tower. And the first reading on his transit instrument was 55 degrees. And afterwards, the second reading was 60 meters farther away from the first location, where the second reading was 40 degrees. And considering the height of the transit instrument can be a theodolite surveyor instrument, the height is 1.5 meters. So what's being asked in this problem is to find the overall height of the tower. All right. And so in this video, I'll be presenting two ways or two methods to solve for the height of the tower. And the first method is by using the law of sines. And the second method will be using the formula for right triangles. I have here the first method by using the law of sines. Law of sines say side A divided by opposite angle sine of A is equal to side B divided by the sine of the angle opposite of B, and this is equal to side of the triangle C divided by sine of the opposite angle C. So here is an illustration of the triangle where we can learn a little more about law of sines. We have here the sides A, B, and C, and the angles, internal angle of the triangle A, B, and C. So that means here on the law of sines A, that means side A divided by the opposite angle of sine of A is equal to B, the side of B, divided by the opposite angle of sine of B is equal to side of the triangle C divided by the opposite sine of angle C. In the first method, we'll be utilizing the triangle siding based on these two angles over here. So we'll be taking this triangle over here and consider this, trying to figure out what this length is, and then we can take the sine of 55 degrees that will include the height and this side of the triangle. Okay. Since in here we have the height of the transit, that's 1.5, so we should subtract this distance from here to here, from the ground to this point, from the overall height of the tower. So considering this triangle, so we can have this side minus the height of the transit, so minus 1.5. All right. So in here, based on the illustration, we now consider this side distance of this, the length of this side, as Z, and the height from the top of the tower to the transit where the siding or the readings were made, as a height of, do it, Y. And so considering this triangle now, this whole thing right here, where we have the side Z and side 60 with the reading over here of 40, and considering this 55 degrees right here, so this angle over here then is, since this line right here is a straight line, so this is 180 degrees. So this angle is considered 180 minus 55. So that's the measurement of the angle of this opposite of this 55 degree angle. And considering this angle over here, since the sum of all the internal angles of a triangle is 180, so this means this angle over here is then 180 degrees minus 40, and then minus this angle, which is 180 minus 55. So from here now, then this angle over here comes up to 180 minus 55 is equal to 125 degrees. And in here, this angle over here then is equal to 15 degrees. That is 180 minus 40 minus this angle minus 125. That is 180 minus 55 comes up to
15 degrees.
So we have internal angle, 15 degrees, 125, and 40 degrees. Since we're using this whole triangle over here, we find for the value of z by using the law of sine, where we can find z divided by the sine of 40 equals sine of 60, that's considered b, divided by sine of the opposite angle, that's sine of 15. By using the law of sines, we have here now z divided by sine of 40. So we have here z divided by sine of 40, that's 40 degrees, is equal to this side, that's considered b, that is 60, divided by sine of b, where we consider this 15 degrees as sine b, angle, internal angle b, so that's sine of 15 degrees. We will find the value of z. Z is equal to 60 times sine 40, so that's 60 times sine of 40, sine 40 degrees, divided by sine of 15, that's 15 degrees. So now, since we have found the value of z over here, we consider this triangle right here with the angle 55 degrees right there, and this height right here from the top of the tip of the tower to the base is y, so we consider this triangle. That triangle now taken from the initial sketch, taken from here, this triangle right here. This triangle now, we're utilizing the right triangle formula since we have found the value of z already. So with from the relationship of these sides and angle, we have the formula sine of 55 degrees is equal to y divided by z. Finding for the value of y, that z multiplied to sine 55, so y is equal to z times sine of 55 degrees. Since we have found the value of z already, all we have to do is substitute the value of z on here, so we can find the value of y. And the value of z is 60 times sine of 40 divided by sine of 15. So we're using this value of z. So y now is equal to, putting the value of z from earlier, that is 60 times sine of 40 degrees divided by sine of 15 degrees times sine of 55 degrees. And by using our calculator, y is equal to 122.06 meters. Since the value of y is just part of the total height of the tower, so we have to consider the height of the instrument, the surveyor instrument, that is 1.5 meters. And so we're taking into account the height of the transit, 1.5 meters. Since in here the overall height of the tower is y plus the height of the instrument, that is 1.5 meters. So the total height is equal to 1.5 meters plus y, and we have y over here, so h is equal to 1.5 meters plus 122.06 meters. So this both meters. So height now is equal to 123.56 meters. So that is our final answer. We move on to the second method, where we're using the formula for right triangles. And for the second method, we'll be considering the total triangle over here. We have the 40-degree angle over here, and we have this distance, unknown distance, so this needs to be solved. And I designate this distance from here to here as x. So now we're considering the whole triangle and the smaller triangle over here. So we are here on the second method by using the right triangle formula. And we have the illustration over here. The angle over here is 40 degrees and the inner triangle is 55 degrees. And the height is y. And here designated the distance from the base of the tower to the first reading as x. And the other distance on the base is 60. So in here we're using the right triangle formula. Y opposite and the base, so that means we're using the formula tangent, where tangent of an angle is equal to the opposite side divided by the adjacent side. So we're using two tangents of these two triangles, one tangent over here and one tangent over here, and we're equating, we will have two variables x and y, and then equating y into the second equation, or vice versa. So we have to do that. So we'll be formulating two equations since we have two unknowns over here. All right, so let's do it. So first equation, we'll be using the big triangle. So that is now tangent of this angle right here. It's 40 degrees is equal to opposite side is y divided by the adjacent side. That's 60 plus x. And from this equation, we can take the value of y as our subject. So y is equal to tangent of 40 degrees times 60 plus x. So this will be our equation 1. And then we'll be formulating our equation 2 by taking into consideration this is smaller triangle over here. So we take the tangent of that triangle also. So tangent of 55 degrees equals y divided by adjacent x. Our aim here is to find the value of y. So from here we'll be using this as a second equation, but our subject will be x. So we'll be substituting value of x into equation 1 to get the value of y. So from here now, x is equal to y divided by tangent of 55 degrees. We just switch position right there. All right, so this is equation 2. So now all we have to do to find the value of y, all we have to do is plug in the value of x in here into equation 1. So that is value of x, so that's 2 to equation 1. So we have now y is equal to tangent of 40 degrees times 60 degrees plus x, where the value of x is y divided by tangent of 55 degrees. Simplify the equation. So this is now tangent of 40 degrees multiplied by the quantity 60 times tangent of 55 degrees. Then plus y all over tangent of 55 degrees. So simplifying further, so that is now y times tangent of 55 degrees equals tangent of 40 degrees times the quantity 60 times tangent of 55 degrees plus y. Distributing tangent of 40 degrees, this is equal now to 60 times tangent of 40 degrees times tangent of 55 degrees plus tangent of 40 times y. So y times tangent of 40 degrees is equal to y times tangent of 55 degrees. So from here, combining like terms And simplifying the equation further, we have y times the quantity tangent of 55 degrees minus tangent of 40 degrees equals 60 times tangent of 40 degrees times tangent of 55 degrees. So y is equal to 60 times tangent of 40 degrees times tangent of 55 degrees, all divided by this amount. So tangent of 55 minus tangent of 40 degrees. From here, by using our calculator, the value of y is equal to 122.06 meters. And from earlier, the formula for total height of the tower is equal to y plus 1.5 meters. So this is now 122.06 plus 1.5 meters. So total height is equal to 123.56 meters. So that is our final answer. So that's the same value as what we have found on the first method, 123.56 meters. So they're both the same. All right, it's final answer. And so that's all for now. And for those new to my channel and for those who have not subscribed to my channel yet, I would appreciate it if you can hit the like button and subscribe for more interesting and informative videos. Have a great day, everyone. Thank you for watching. I will see you in the next video. Bye.